Okay. So I'm not going to go full screen here because things will get screwed up, I think. And I don't want to play with the technology right now. You can see well enough, right? So geometric optics has to do with this idea of ray, that light travels in a ray. Light goes in a straight, goes straight until something happens to it that causes it to change direction. All right. And we can imagine light as a ray of light, like a laser beam, right? In a laser beam, the light just leaves the laser and it goes in a straight line, right? And the only way we see things is when light happens to be able to go into our eyes. So how it goes into our eyes is it reflects the light from whatever the light source is, reflects off the object. And when it reflects off the object, some of that reflection goes into our eye, right? The object itself that we are looking at is not producing the light that we see, unless you're looking at the lamp, the light bulb itself, right? But if you're looking at well, in the computer screen, it's actually producing the light. But if you're looking at your keyboard, right, the keyboard is not producing the light. The lamp in your room is producing the light, and that lamp sends light to the keyboard, and light bounces off of the keyboard and into your eye, and then you can see the keyboard. That makes sense to everyone? Looking down here at the picture in the bottom right of the slide here, the idea here is that the source, if you look at the rays from the source, are all parallel to each other, but the thing that the light is reflecting off of, nothing is perfectly smooth. Therefore, the reflections off of that surface go in all kinds of different directions. That's why we can all see the desk, or we can all see the whatever it is that we're looking at, right? Because when the light reflects off of the surface of something, it reflects in every different direction. The exception to that is if the surface is perfectly smooth, and that's what a mirror is, right? A mirror is, in theory, the surface that things are reflecting off, the light is reflecting off of, is perfectly smooth, and therefore the light goes into the mirror parallel and it reflects off the mirror parallel, right? But most objects are not mirrors, so the surface has imperfections and the light bounces in all kinds of different directions. Good? That makes sense to everyone? Can we kind of visualize all of this? Hopefully it's kind of common sense. I would imagine that most of you had a basic idea of this, right? No one thought that your chair is producing light and that's how you're seeing it, I hope. Okay. The next slide is a vocab slide. Why am I not going to the next slide? Here we go. All right. Some vocab that we need to know about and understand when we're dealing with optics, right? The object, the image, right now as you see, it says vocabulary for mirrors, the object, the image, the angle of incident, and the angle of reflection. All right, you can copy down those definitions if you're taking notes, right? You have this PowerPoint is in Schoology, and I believe I put it in this week's folder. So you have that, you can access it yourself also, right? The object is the thing that the light is coming from, that the light goes into the mirror, right? Again, it doesn't have to be the source of the light. When you're looking at yourself in the mirror, you are the object. you're not producing the light, right? The light is bouncing off of you and going to the mirror. So the object is the thing that the light comes from you and goes into the mirror. The image is the reflection, right, of that object. So when you see yourself in the mirror, you're seeing an image of yourself. I think that's fairly common sense. Okay. Finally, angle of incidence and angle of reflection. Right, the angle of incidence is the angle between the ray of light going from the object to the mirror and the normal to the mirror surface. So again, the idea is I might have to go and leave the share and look at the screen here, right? If this is the mirror, right? Here is the mirror. That's the surface of the mirror. And here's the object, your beautiful face. I don't have to draw noses and mouths anymore. It's a bonus from the pandemic. Makes my drawings, my awesome art skills that much better, right? There's the object. So in order to see yourself in the mirror, right? Let's say you're looking at your chin. You're looking at your chin. Then the light from the lamp reflects off of your chin and it goes to the mirror. And then it reflects back to your eyeball. I missed. Reflects back to your eyeball. Right? So that's your incident ray into the mirror, incident ray. Reflection ray, reflect off the mirror. That's your reflection ray. IR. And the angle of incidence and angle of reflection are from the normal, not from the surface, but from the normal to the surface. Right? Let's pick up a nice color. From the normal. So this is your angle of incidence, and this is your angle of reflection. Right? Right here. Those are your angles of incidence and reflection. Okay? Does that make sense? We okay with that idea? Hopefully. Okay. Let's go back to sharing my screen. All right, so object, the image out here. Whoops, let me stop sharing a section. All right, the object is your face in my drawing here. The angle of incidence, angle of reflection are in here. The image, I'm looking at my chin. The image is back here. Right, there's my chin. The point of my chin is back here on that. My drawing isn't very good, but there's my chin. The image is back there, right, as we have our face. Good? All right, share again. PowerPoint. Okay. Key, big important thing for mirrors, angle of incidence equals angle of reflection, always in every kind of mirror. in every mirror. And we're going to deal with 3 kinds of mirrors: a flat mirror and 2 different kinds of curved mirrors, called convex and concave, depending on which way the curve is, right? But in any kind of mirror, the angle of incidence equals the angle of reflection. And it turns out for a flat mirror that the object distance and the image distance are the same. So the image, when you look at yourself in the mirror, your image is the same distance behind the surface of the mirror as you are standing in front of the surface of the mirror, right? For a flat mirror. That does not hold true for the curved mirrors. Okay, right? If you ever look for curved mirrors, just since I'm rambling on, you look, I'm assuming you guys are all seniors except for Katie. So do you all drive?
Yeah, I do.
Okay.
Yeah.
So if you have a relatively new car, the passenger side mirror, right? The passenger side mirror has that little sign in it, that little writing in it, says objects appear further than appear, what does it say? They appear closer? Objects appear closer.
Objects are closer than they appear.
Right. Oh, that's what it says. Objects are closer than they appear. Right? Because the image of that object, the other cars that you're looking at, is not the same distance as the object is. Right? The image appears to be further away in the mirror than the object actually is compared, from where the surface of the mirror. But for a flat mirror, the object distance and the image distance are always the same. Right? We'll get to all of that stuff. I got 4 minutes. What's next? The ray activity. Okay, so we'll just do our simulation here because I have to do a full screen for this. Right? So we're not going to actually get to do can you guys see are you seeing the simulation here? Or are you seeing the PowerPoint still?
PowerPoint.
We see the PowerPoint.
Shucks. I was a little afraid of that part. I'll have to figure that out. All right, so we only got 4 minutes left anyway. We'll pick up here tomorrow. Okay. We'll pick up here tomorrow once I figure out how to share the simulation with you. So by the time I figure out how to get the simulation going and have the PowerPoint full and hit the power and get it to see you, the class will be over. All right, so we'll pick up here with this idea of ray diagrams, and then we'll get into the curve mirrors also tomorrow. All right. All right, guys, have a good day, and I'll talk to you all tomorrow.
You too, Mr. Sugar.
So long.
Mr. Shuka.
All right, I can stop.